In the vast expanse of our solar system, amidst the celestial ballet of planets and moons, lies a hidden gem, Europa. Orbiting the mighty Jupiter, this icy moon holds secrets that have captivated scientists and dreamers alike. Europa is a world of stark contrasts, a place where icy plains meet the potential for hidden oceans. Its surface, a tapestry of cracks and ridges, speaks of a dynamic and ever-changing landscape. Beneath this frozen facade, scientists believe, lies a vast, potentially life-harboring ocean. Our journey to Europa begins in the 17th century with the Italian astronomer Galileo Galilei. In 1610, Galileo, using his rudimentary telescope, observed 4 celestial objects dancing around Jupiter. These were the Galilean moons, Io, Europa, Ganymede, and Callisto. Among these, Europa, the smallest of the 4, would later emerge as a prime candidate in the search for extraterrestrial life. Early observations of Europa were limited to its appearance, a small bright disk against the backdrop of Jupiter's massive form. The discovery of Europa's potential subsurface ocean revolutionized our perception of this icy moon. The possibility of a vast, salty ocean hidden beneath Europa's icy shell has propelled this moon to the forefront of astrobiological research. This ocean, scientists believe, could contain more water than all the oceans on Earth combined. The interaction between Europa's ocean and its rocky mantle could provide the necessary chemical ingredients for life to arise. Europa offers a unique opportunity to explore the question of life beyond Earth. Europa's surface is a captivating spectacle, a stark contrast to the familiar landscapes of Earth. Covered in a thick layer of ice, it reflects sunlight with a brilliance that makes it one of the most reflective objects in our solar system. But this icy shell is far from smooth and pristine. It is crisscrossed by a complex network of cracks, ridges, and dark streaks, each telling a story of geological activity. One of the most striking features of Europa's surface is its relative lack of craters compared to other icy moons. This suggests that the surface is relatively young, constantly being renewed by geological processes. Scientists believe that tidal forces from Jupiter create friction within Europa's interior, generating heat that keeps the subsurface ocean liquid. Section 2. The Dance of Tides. Europa's orbit around Jupiter is slightly elliptical, causing the gravitational pull from Jupiter to vary. These tidal forces squeeze and stretch the moon, generating heat within its interior. This tidal heating is thought to be the primary source of energy that keeps Europa's subsurface ocean in a liquid state. The constant pushing and pulling of Jupiter's gravity create friction within Europa's ice shell, causing it to crack and shift. This process, known as tidal flexing, is responsible for the intricate network of cracks and ridges that scar Europa's surface. Europa's gravitational interactions with its neighboring moons, Io and Ganymede, also play a role in shaping its surface. These interactions create resonances that influence Europa's orbital and rotational periods, amplifying the tidal forces at play. Section 3. Plumes of Hope. Observations from Earth-based telescopes and the Hubble Space Telescope have provided evidence for water vapor plumes erupting from Europa's surface. These plumes, if confirmed, offer a potential window into the composition of Europa's subsurface ocean. The detection of water vapor plumes has fueled speculation about sampling Europa's ocean without drilling through ice. If these plumes are connected to the subsurface ocean, they could provide a way to study the ocean's chemistry and search for signs of life. The potential for water vapor plumes to reveal the secrets of Europa's hidden ocean has made them a prime target for future exploration. Section 1. An Ocean's Embrace. Beneath Europa's fractured icy exterior lies a vast global ocean. Evidence suggests this subsurface ocean is a colossal reservoir that dwarfs all of Earth's oceans combined. This hidden ocean is thought to be saltwater, similar in composition to Earth's oceans, and exists in liquid form due to a balance of heat and pressure. The immense pressure from the overlying ice sheet prevents the water from freezing. Measurements of Europa's magnetic field suggest the presence of a conducting layer beneath the surface, consistent with a salty ocean. The detection of water vapor plumes erupting from Europa's surface further supports the existence of a subsurface reservoir. Section 2. The chemistry of life. The presence of liquid water is a fundamental requirement for life as we know it. But water alone is not enough. For life to thrive, a complex interplay of chemical ingredients and energy sources is necessary. Scientists believe that Europa's subsurface ocean may possess the necessary chemical building blocks for life. The ocean is thought to be in contact with the Moon's rocky mantle, allowing for the exchange of minerals and chemicals. This interaction could provide the essential nutrients and elements required for life to emerge and evolve. Hydrothermal vents, similar to those found on Earth, could provide localized environments where life could flourish, even in the absence of sunlight. Section 3. Energy for life. Life, in all its forms, requires energy to survive and thrive. On Earth, the primary source of energy for most ecosystems is sunlight. However, in the depths of Europa's subsurface ocean, sunlight is absent. Scientists believe that chemical energy, rather than sunlight, could fuel a potential biosphere on Europa. The interaction between Europa's ocean and its rocky mantle, driven by tidal forces, could create chemical gradients that organisms could exploit for energy. Hydrothermal vents, if present, would be particularly promising locations for life. These vents release heat and chemicals from Europa's interior, creating localized hotspots of energy. Section 4. The search for biosignatures. The search for life on Europa is a challenging but ultimately rewarding endeavor. Directly accessing the subsurface ocean, buried beneath kilometers of ice, presents significant technological hurdles. However, scientists are developing innovative approaches to search for evidence of life, known as biosignatures, that could be detected remotely. One promising avenue is the analysis of material ejected from Europa's subsurface ocean through water vapor plumes. If these plumes are connected to the ocean, they could carry telltale signs of life. Future missions equipped with sensitive instruments could analyze the chemical composition of these plumes, searching for organic molecules or other indicators of biological activity. Analyzing the composition of surface ice could provide clues about the ocean's chemistry and the potential for life. Our fascination with Europa has fueled numerous missions to study this enigmatic moon. These missions have provided invaluable insights into Europa's composition, structure, and potential habitability. The exploration of Europa began in the early 1970s with the Pioneer 10 and 11 spacecraft. These pioneering missions provided our first close-up glimpses of Jupiter's system, including fleeting but tantalizing images of Europa. The Voyager 1 and 2 spacecraft, launched in 1977, revolutionized our understanding of the outer solar system. The Galileo spacecraft, which orbited Jupiter from 1995 to 2003, provided compelling evidence for a subsurface ocean and fueled speculation about its potential to support life. The Pioneer 10 and 11 spacecraft, launched in 1972 and 1973 respectively, marked the beginning of humanity's exploration of the outer solar system. These robotic explorers provided our first close-up views of Jupiter and its moons, including Europa. While the Pioneer spacecraft were not specifically designed to study Europa, their flybys provided valuable data that hinted at the moon's unique nature. The images they captured showed a world with a surprisingly smooth and bright surface, crisscrossed by a network of dark lines. The Pioneer mission sparked further intrigue into the nature of Europa and paved the way for more detailed exploration by subsequent missions. The Voyager 1 and 2 spacecraft, launched in 1977, embarked on a grand tour of the outer solar system. Their flybys of Jupiter and its moons in 1979 provided groundbreaking insights into the Jovian system, including observations that revolutionized our understanding of Europa. The Voyager spacecraft carried more advanced imaging systems than their Pioneer predecessors, allowing them to capture detailed images of Europa's surface. These images revealed a world far more complex than previously imagined, with a surface crisscrossed by an intricate network of cracks, ridges, and dark streaks. The Voyager's observations suggested that Europa's surface was geologically young and active, constantly being resurfaced by processes yet to be understood. The Voyager missions transformed Europa from a simple icy moon into a prime candidate in the search for extraterrestrial life. Section 4. Galileo, a closer look. The Galileo spacecraft, launched in 1989 and arrived at Jupiter in 1995, was designed to orbit Jupiter, allowing for repeated observations of its moons, including Europa. Galileo's mission was to study the Jovian system in unprecedented detail, and its observations of Europa were particularly groundbreaking. The spacecraft carried a suite of instruments, including cameras, spectrometers, and a magnetometer, which provided a wealth of data about Europa's composition, surface features, and subsurface structure. Galileo's images of Europa revealed a surface even more complex than previously imagined, with evidence of ice rafts, chaotic terrains, and regions where the surface appeared to have been pulled apart and filled with new material. One of Galileo's most significant discoveries was the detection of a magnetic field around Europa that varied in response to Jupiter's magnetic field, providing strong evidence for the presence of a salty subsurface ocean. Section 1. A new era of exploration. Galileo's discoveries have ignited a new era of exploration focused on Europa and its potential for life. Space agencies are developing missions to probe Europa's secrets with advanced technologies. These missions aim to answer questions about Europa's habitability, ocean composition, icy shell, and potential hydrothermal activity. They represent a bold step in understanding life beyond Earth. The European Space Agency's JUICE mission and NASA's Europa Clipper will revolutionize our understanding of Europa. These missions will study Europa's interior, surface, and atmosphere. The data will shed light on Europa's potential for life and provide insights into icy moon's evolution. Exploring Europa is now a tangible reality, with the potential to rewrite our understanding of life in the universe. Section 2. JUICE, Jupiter's Icy Moons Explorer. The Jupiter Icy Moons Explorer, or JUICE, led by the European Space Agency with contributions from NASA, aims to study Jupiter's moons, Ganymede, Callisto, and Europa. Scheduled for launch in 2023, JUICE will embark on a 7-year journey to Jupiter. It will orbit Jupiter and make close flybys of its icy moons. Equipped with 10 state-of-the-art instruments, JUICE will study the moon's geology, composition, and subsurface structures. The mission will also make close flybys of Europa, providing valuable data about this potentially habitable world. JUICE's observations will complement NASA's Europa Clipper mission, offering a comprehensive view of Europa. Section 3. Europa Clipper, Unveiling a Hidden Ocean. NASA's Europa Clipper is a flagship mission dedicated to exploring Europa and determining its potential for harboring life. Named after the fast, three-masted sailing ships of the 19th century, Europa Clipper will conduct a detailed reconnaissance of this icy moon, making dozens of close flybys over several years. Equipped with 9 sophisticated instruments, including cameras, spectrometers, an ice-penetrating radar, and a magnetometer, Europa Clipper will investigate the thickness and structure of Europa's icy shell, analyze the composition of its surface and tenuous atmosphere, and study its magnetic field and internal structure. The mission's primary goal is to determine if Europa possesses the necessary ingredients for life, including liquid water, essential chemical elements, and sources of energy. Europa Clipper will search for evidence of organic molecules and other potential biosignatures, providing valuable clues about the possibility of a subsurface biosphere. One of the mission's most anticipated objectives is to study Europa's water vapor plumes, which are thought to originate from its subsurface ocean. By flying through these plumes and analyzing their composition, Europa Clipper could provide unprecedented insights into the chemistry of Europa's ocean without having to land on the surface. The exploration of Europa is still in its early stages, but the future holds exciting possibilities for unraveling the mysteries of this enigmatic moon. Future missions, building upon the discoveries of JUICE and Europa Clipper, could include landers, rovers, and even submersibles designed to explore Europa's subsurface ocean directly. Landing on Europa's surface presents significant technological challenges, but the rewards of direct exploration are immense. A lander could study the composition of the surface ice in detail, searching for evidence of organic molecules and other potential biosignatures. A rover could traverse the surface, exploring different geological terrains and searching for regions where the subsurface ocean may be closer to the surface. Perhaps the most ambitious vision for the future is to send a submersible to explore Europa's subsurface ocean directly. Such a mission, while technologically daunting, would be the ultimate test for the existence of life on Europa. Imagine the discoveries that await us as we venture into this alien ocean, a realm that has remained hidden for billions of years. The exploration of Europa is a testament to human curiosity, our relentless pursuit of knowledge, and our desire to understand our place in the cosmos. The allure of Europa lies not just in its beauty, a stark white orb against the majesty of Jupiter, but in the profound questions it poses about our place in the universe. Beneath its ice shell might exist an ocean vaster than all of Earth's combined, a hidden realm potentially teeming with life. This is not science fiction, but a real possibility. From Galileo's observations to Pioneer and Voyager flybys, each mission has deepened the mystery. Europa, once a distant point of light, is now a tangible target in our search for life beyond Earth. The implications of finding life on Europa, even microbial life, would be staggering. It would mean that life is not a fluke, not unique to our pale blue dot, but rather a phenomenon that could be common throughout the universe. It would reshape our understanding of our place in the cosmos and spark a revolution in scientific thought. But even if Europa proves to be sterile, devoid of even the simplest organisms, the knowledge gained from its exploration will be invaluable. By studying Europa's ocean, its chemistry, and its geological processes, we'll gain a deeper understanding of how icy moons form and evolve, not just in our solar system, but around distant stars. The missions currently being developed, JUICE and Europa Clipper, represent the culmination of decades of research and technological advancement. These sophisticated spacecraft, equipped with state-of-the-art instruments, will peel back the layers of Europa's secrets, providing us with an unprecedented view of this alien world. The data they send back will be pored over by scientists for generations to come, shaping our understanding of planetary science, astrobiology, and the very nature of life itself. The exploration of Europa is not just about seeking answers to fundamental questions about life and our place in the universe. It's also about pushing the boundaries of human ingenuity, about daring to dream big and to explore the unknown. The challenges of sending spacecraft to such a distant and hostile environment are immense, requiring innovative engineering solutions and international collaboration on an unprecedented scale. But the rewards, both in terms of scientific discovery and technological advancement, are immeasurable. The lessons learned from designing, building, and operating missions to Europa will pave the way for even more ambitious endeavors in the future. Imagine landing on the surface of Europa, drilling through the ice, and sending a probe into the depths of its ocean. Imagine establishing a permanent research base on Europa, a stepping stone to further exploration of the outer solar system. These may seem like distant dreams, but they are within the realm of possibility, driven by our insatiable curiosity and our desire to explore the cosmos. Europa is a beacon, beckoning us to unravel its secrets and to embrace the boundless possibilities that lie ahead in our journey among the stars.